Hello and welcome to Cuppa with a Scientist, a brand new podcast by Loughborough University that will interview a different scientist every episode about their academic journey to the top. We will discuss how they went from a confused teenager choosing A-level subjects to a leader in their field, with plenty of weird and wonderful stories in between and golden nuggets of advice for those aspiring to get into science. As well as keeping your ears and brain entertained, we hope this podcast will dispel the myth that all scientists wear white lab coats and give you an insight into how vast the world of science really is. And because the makers of this show are painfully British, we'll be doing it all over a good cuppa. So stick the kettle on and settle in. So before we begin, I better introduce myself, as I'm the person whose voice you're going to be hearing in each episode. Yep, you're stuck with this very average Midlands accent. So I'm Meg, and I'm the PR and Communications Officer at Loughborough University, and I'm also an aspiring scientist. Last year, I made the tough decision to return to university part-time and explore my love of biology. And when reaching this conclusion, I found resources such as podcasts incredibly useful, but I could only seem to find field-specific shows, so shows specifically on physics or one specifically on marine biology. And I personally wanted to create something that gives an overview of all the different fields scientists can work in. And this is what this show aims to do. So from health sciences to computer science to environmental science and social sciences, we're going to cover it all. So whether you're like me and you're considering returning to university, or you're an A-level student trying to decide what to kind of study as a degree when you get into higher education, or even a student that's already doing a degree and you just want to kind of hear from some of the leaders in the field, I'm really hoping this podcast will benefit you and help you on your journey to becoming a scientist. That's enough about me. Let's kick things off. Episode 1, Season 1, here we go. So joining us for our first ever episode is Dr. Tom Matthews, a climate scientist in Loughborough's Geography and Environment Department. You may have actually come across Tom without realising it, because he was part of the team that successfully installed the world's highest weather station last year on Mount Everest. He made headlines at the time, he seemed to be everywhere where you turn your TV on, and he also recently appeared in National Geographic's 1-hour documentary special called Expedition Everest. But more on that later, so let's get into it. Hi Tom, welcome to the podcast. Really exciting to have you here.
Yeah, thanks for inviting me on. This is a fun opportunity.
First of all, what mug have you got today?
So I've got my most colourful special occasion mug with me today. It's from West Africa. It was a gift from Ghana.
Fantastic. And what are you drinking in it? Have you got tea, coffee?
Coffee. It's my vice, unfortunately. Keeps me, well, sharper than I otherwise would be.
Fab. Well, my mug's not as colourful of yours, but we've gone for a little baby Yoda, which says Yoda best on it. So
an encouraging phrase. I think we can all
very encouraging. Yeah, we need it on a gloomy morning like today, especially after some technical issues. But there we go.
We're up and running now.
We are, and we've requested that you bring artifacts onto the show. Have you got anything exciting to show us?
I have, and you actually asked me to bring one artifact, and I cheated. So I'll pile them together so they look like one artifact. Oh. This is a crampon, part one of a set. You need 2 of them, and a GPS unit. This looks quite archaic now, considering that most people use their phone for GPS, but this is a handheld GPS unit. And they are essential bits of glacier kit. If you can do any work on glaciers, you can get by with, perhaps not the greatest waterproof and warm clothes for a little while, but you can't really get away without having crampons and a GPS unit. The GPS unit, this one I used to keep me away from dangers on the glacier I did my PhD work on. You should be able to navigate without GPS, but to do things like avoid crevasses and moulins and the fog. And a moulin, for those that don't know, is a glaciologist's worst nightmare. They are essentially holes in a glacier, and a glacier can be hundreds of meters thick. They're holes in a glacier that streams fall down, streams flowing over the surface of the ice, they fall down. They can be buried by snow, so you can't see them, and they're big enough to swallow a person or potentially to swallow a couple of people. And if you're moving around in the fog, you can't necessarily orientate yourself that well to where you are. You should be able to know approximately where you are, but essentially it's the wrong meter, then you can end up in trouble. So you need one of these to keep you safe, to let you know exactly where the moulins are that you've identified when there hasn't been snow there, to stay clear of them. So a bit of an extended explanation as to what I've got with me, but I feel I need to justify a relatively boring bit of kit, which is a handheld GPS unit.
So it looks archaic, but actually incredibly important.
Yeah, that's a more succinct summary of it. Yeah.
You're a climate scientist, so for somebody that has no idea about the field that you work in, can you explain what that means?
Sure. So firstly, what is climate? So climate is really the type of weather you can expect. So the meteorologist deals with the weather, telling you what might happen tomorrow in terms of the weather, or the day after that. The climatologist tells you what type of weather is possible over longer timescales. So how cold can it get in December in Loughborough on average? How warm can it get in July on average? So climatologists are interested in those kinds of things. You might think, well, why do we need that if we can predict the weather, 1-2 days out? Why do I need to know on average what can happen? Well, if you want to know how warm to make your house, how thick to have the insulation, or how high to build your flood defences, you need to have an idea of what to expect on average. So that's the field of climatology. And myself, as a climate scientist, I'm interested in the extremes. So how hot can it get in the summer? And how can that change as we humans change the climate? So I'm interested in how the statistics of weather change over long periods of time, and in particular, how the extremes change over periods of time, because it's the extremes that really affect us.
So you kind of touched on it a little bit there about the research areas that you look at. So we've mentioned the coldest that you look at Everest, and you've kind of touched on heat. Can you kind of give an overview of the research you're currently doing, just quickly, just to show how vast it is when it comes to climate?
Yeah, sure. So yeah, as alluded to, really touched on this a little bit. So extremes, I'm interested in how they change as we modify the climate. And heat is one thing that I find particularly interesting because it affects a huge number of people worldwide. In the UK, we all know that it's not very nice when it gets very hot during the summer. We have trouble sleeping, but that's about as serious as it gets. Not quite, actually. I've glossed over a pretty unfortunate reality of heat even in this country, and that is when it gets very hot, more people die in the summer. People with pre-existing health conditions, the elderly, and those with chronic health problems, they see an increase in the likelihood of dying, unfortunately, during very hot weather. But we don't suffer anywhere near the amount that people in the tropics and subtropics do, places that are already very hot, places like West Africa. In those places, already very warm, and the weather, the hot weather, already affects people's ability to earn a living and to live a healthy and productive life. So in those places, climate warming, and it's warming just as much there, in fact more than it is here, is really worrying. There's not so much of a safety margin. But also, I'm not just about extremes. The reason I was going to Everest wasn't just necessarily to look at the temperatures there. It was to look at the impact of the climate on something else. So I also look at applied climatology. And applied climatology is really how the weather, variations in the weather, the statistics of weather affect other things. In this case, the other thing is glaciers. Glaciers, these huge blocks of snow and ice that are stored in the mountains or reside in the mountains, and as they melt, they release water to communities downstream. And the glaciers in the Himalayas provide water to hundreds of millions of people downstream. As the climate warms, we expect them to retreat. So they're really important things to look at, worthy of our study because of the impacts on people.
Do you think there's misconceptions around when you introduce yourself as a climate scientist? For example, if you're at a dinner party and you say you're a climate scientist, do people ask you, well, how do we solve climate change? And if that is the case, what is your response to them?
Yes, completely is the answer with respect to misconceptions. So climate change is rightly, a topic that is in the public eye quite a lot. There are downsides to that in terms of people get issue fatigue, but it's good that generally it's a good thing it's in the public eye, because according to me at least, it is one of the grand challenges of our generation, if not the grand challenge of our generation, because it affects almost everything that we do. Everything we built has been against the backdrop of a reliable and a stable climate. Everything we've got is optimized to the climate that we've experienced in the past, and that's changing. So greatness in the public eye. But then, yes, the questions that I would normally get when someone knows I'm a climate scientist, and this isn't just informal conversations. This is often when I have spoken to the media. It's been around this issue of, or rather, it's a very blurry line between what's going on with the climate system, and then the next question, which is, what do we do? What's society's response? How do we address the problem of climate change? And from a climate point of view, the answer is really boring and really simple. We stop emitting greenhouse gases. That's it. We have to become carbon neutral. And so it's a one sentence thing. But often that's not really what people are interested in. They want to know how we get there, how we get to that point, how we decarbonize the economy. And I'm an interested observer in that debate, but that's not what a climate scientist's remit is. Climate scientist's remit typically is the physical system, how the climate system works, not policy, which is essentially what that question is asking. It's a bit like asking an astrophysicist whether we should settle on Mars. It's a different thing.
Good analogy.
Yeah, you can separate. There's physically, is it possible? And what are the physical things we need to consider? But it's a policy question and one about your worldview. Now, you can objectively arrive at the idea or the conclusion. You can rationally get to the point that decreasing our carbon emissions, so we're carbon neutral, is in the world's best interests. But the complexity comes when you recognise things like there are hundreds of millions of people in places like India that don't have reliable access to electricity. And if they were to use coal, to burn coal, they would get access to electricity much faster and more cheaply than they would by using renewable energy sources. The world would be a bit worse off if they did that. And ultimately, those Indian citizens might be in the long run, but not necessarily next year or the year after. So you can see it's a really complex issue. And we have to, you have to weigh up different competing interests when arriving at what to do. So that's why it's beyond the remit of me as a climate scientist. I'm saying interested observer in those debates, but expertise stops with climate and the physical stuff. So extended answer, but yes, there is often misconception about what I know, what I'm an expert in.
No, I think that's a really good explanation, and I know from previous media work that we've done, everybody thinks that you have the answers when just getting mixed up with what it is you actually study.
Yeah.
So let's take it back a bit. So obviously you are kind of really high up in your field now. You've done some amazing things, but how did we get there in the first place? So what did you want to do when you were younger? Has this always been something you dreamed of?
No, not at all. And I think that's common for many academics. You ask your average 4-year-old, we can even go a bit older with that age, what they want to do, and they probably won't even know an academic is a thing, that you can be an academic. And so no, I think when I was a kid, the only theme that I was thinking about this that's consistent is that it was public service related. So it was policeman, doctor, fireman, and then when I was a teenager, I wanted to be in the military. Actually, I wanted to be a soldier. I don't really know why. So yeah, I was never interested in making money, I would say, but I was interested in doing something related to public service. The only kind of cliche job I didn't want was train driver. I don't think I ever wanted to be a train driver. So this was looking back now, this is a surprise to me that I am where I am, but looking at sort of key events, it makes sense I am where I am too. But from childhood, no, this is not a trajectory I ever imagined.
Definitely got that theme within those jobs of helping people in some capacity, which I guess you could argue you're trying to do still today. I mean, it's at least you're kind of on the same theme, whereas I wanted to be a guinea pig trainer when I was growing up. So
I didn't know that was a job, a guinea pig.
I don't think it is, but I wanted it to be. So at least yours was sensible.
Well, there's good creativity there. Yeah.
So let's skip forwards a bit. So you wanted to work in some kind of public sector capacity. I've personally found, and I don't know if this is your experience as well, that I always had a love for science. And when I finished my A-levels, I didn't know what to do next. So I know I liked it, but I didn't know anything about, the different roles I could go into. So could you kind of give us an insight into, your GCSE selection, what happened at A-level, and then how we got into a higher education and then where you are today?
Yeah, I was reflecting on this too, and I suppose it's an interesting trajectory. It isn't typical of many scientists, but science was one of my stronger subjects in school. But then when it came to GCSEs, so let me think back. Yeah, did well at GCSE, but then going into A levels, I didn't select a science because I didn't actually enjoy the sciences that much. So I selected geography, which is consistent with where I ended up, history, and physical education were my three A levels. And I mean, I was lucky in the sense that the advice I always had from my parents was choose something you enjoy, and don't necessarily think about what comes next. So I know that that's very lucky because, my parents had reliable, stable jobs. And it was never, I suppose that's why I was never really thinking about, I must go to university, I must select a trajectory that allows me to earn a good income, because it had never been, my parents weren't wealthy, but money had never been something to worry about. So I think that's an important kind of background to the way in which I was thinking even as a teenager, and asking my parents those kinds of things. Oh, I'm thinking about studying this or that. They weren't thinking, he's our future. He's going to, help us secure ourselves financially going forwards. They would also offer the advice to choose something you enjoy. And the sciences, I was reflecting on this, why I didn't enjoy them so much, sciences and mathematics too, which is another very important subject, or something I use every day now. And I think it's because it's not terribly applied wasn't in schools when I was there. So you wouldn't necessarily see the relevance of what you were doing. Geography, which I think was my favourite subject back then, I liked because it was real world. You were looking and talking about things in the real world. Now the sciences and the mathematics I use is all applied. You come at it from the problem. So you want to understand how fast the ice will melt given a certain temperature and wind speed, and how sunny it is on a particular day. The answer is physics, or the answer is in the physics world. So you're then motivated to go through the relatively dry motions of learning the theory. So A level, I took those subjects, history, geography, and physical education, and enjoyed them, and got the good enough grades that I needed to go to university.
So which university did you select, and what course did you choose to do?
Well, I actually selected Loughborough University as my university of choice, which is where I ended up. And I selected Loughborough because of its sports. And I came to Loughborough and didn't play any sports at all. So a bit of a strange decision process there, I suppose, but reflected where I was at the time. I think one thing to keep in mind for anyone listening to this and planning their future, one thing to reflect on is that you make these really important decisions at a stage in your life that you're probably least well equipped to make them, because they are important decisions, and your interest can be changing quite quickly at that time. So for me it was sports, and I still like sports, but it's certainly not doesn't take center stage in my life like it did. So I think it's important to reflect on what really drives you, to try and take some perspective, have some perspective when you are making that decision. Ultimately, it didn't cost me anything at all. That I chose a university that was famous for its sports, but it's also very good for a number of other things. I just found those other things when I got here.
So what was the degree that you chose to do at Loughborough?
Good question. I didn't answer that one, did I? Geography.
Geography.
I chose to do geography here, yeah.
And how was your university experience? When you started geography, did your interest change as you went through the degree? And did you do a master's?
Yeah, very good question. Because when I started, I didn't really know which field geography I would find most interesting, because again, not everyone listening will know what geography is like at university, but at Loughborough you study, then it was just a BSc geography. Now you can also study a BA in geography. But then it was a BSc, and you could choose a mix of physical and human geography. You would have to do some of both, but then you could choose to weight your degree more heavily in one than the other. And I didn't know what I what I would weight the degree towards when I started. I found human geography interesting and physical geography interesting. But then quite quickly I found it was the physical geography that I really liked. It was the landscapes, the atmosphere that I really found interesting, the atmosphere being weather and climate. But the big transformation for me was, I would say, after my second year at university, I went on the Erasmus exchange program. So that saw me go and study in Sweden for a year. And that during that process, not quite sure what it was, but I took my studies more seriously when I came back. I think it was being exposed to a different culture. I mean, it's not a very different culture in Sweden, but what was different was seeing really motivated students from all around the world at the university that I had the exchange with. And I think that really taught me that, or opened my eyes to the fact that education is a privilege, and what you take from it is really up to you. It's an open door. Once you're in that position, you can either coast and get your degree, or rather you can go through the motions and get your degree as you were. But if you do enjoy it, then there's no reason to not really, aim for the stars. So I suppose it gave me that academic ambition, and I came back and took my studies a lot more seriously. I really enjoyed doing my dissertation, which was an independent piece of study. And then towards the end of that, I was speaking to, I think, my personal tutor at the time, and he said, have you thought about doing a PhD? And I hadn't thought about doing a PhD at that point, because I had no idea really what a PhD was. I looked into it, and I found that you got a scholarship that you would be essentially paid to study. And I thought, well, okay, that sounds good. And then I remember almost kind of a really clear moment when I was thinking, what else would I rather do right now? So when I leave university, what else would I rather do if it wasn't a PhD? And I couldn't think of anything. I couldn't, going to do any type of work. I couldn't imagine it being more fun than the things I was currently doing. And when I say currently doing, I mean more the dissertation type research. And I'd just come back from a field trip to the Arctic, and I thought, I can't imagine doing anything more fun than this. So I went straight into a PhD then. I applied for one again at Loughborough and got it. And that's an relatively unusual trajectory, to stay at the same institute and to not do a master's. But it happened to be right for me at the time, because the PhD, you really have to select something that you're passionate about. You're going to spend 3 years on it. And the topic that I applied to my PhD on, I was passionate about, found it really interesting. And it's no coincidence that it's at the same university you've done your undergraduate degree in, because the academic staff there teach things that are aligned to their interests, and that sparks the interest in you. So then it's no surprise that the PhD that you find most attractive is also at the same institute. So it sounds perhaps strange to stay in the same place, but there's also some logic to it too.
I mean, Loughborough's a wonderful place, so no harm in sticking around there. Just going back a bit, so you mentioned your dissertation. What did you do your dissertation on?
It was the response of Scandinavian glaciers to the North Atlantic Oscillation. So in layman's terms, that was, how does variability in the winter weather affect how big glaciers in Scandinavia get? They're not quite how big they get, but do they have good or bad years, depending on this particular weather pattern?
And what did you conclude?
I concluded that when the North Atlantic Oscillation is very positive, and that means for the UK, we experience this thing called the North Atlantic Oscillation. When it's in a positive phase, we get relatively warm and wet winters. So if you can remember back to 2013-14, that was a very positive year. We had a very wet winter. I can't myself remember last year. I think it was pretty positive. So we had because I know we had a very warm and wet late winter. When the conditions are like that the conditions that give us the warmth and wetness in the UK, that also delivers lots of snow to the Scandinavian glaciers. So they have a relatively positive year. They gain some mass, they gain that extra snow, and that can allow them to, well, if everything else is equal, to just inch a little bit further down valley. They get a little bit bigger.
So did your PhD, was it along similar themes to your dissertation?
Yes, it was actually. It was, again, assessing. I'm trying not to use the technical words because they'll make it sound more boring than it was. So the layman's interpretation was trying to figure out a way of modelling melt rates on glaciers given very limited weather data. Because, and as you'll see a theme, we talk about the Everest expedition, a problem with trying to work out what's happening with glaciers and how quickly they're melting, or whether they may even be growing in some parts of the world. The difficulty in trying to do that is we don't have weather data from where the glaciers are, because the glaciers are in really hard to reach places, in remote mountain ranges, and this can come as a surprise to people in the era of big data, where you open your phone and you can instantly have a weather forecast for any spot in the world. Well, that's the best guess most often, and the best guess is pretty good in a city because we've got lots of weather stations around. Best guess on the Tibetan plateau or in the Himalayas or high in the Andes might be a very long way from reality because there's just no measurements of it. You have to actually put a sensor somewhere to measure what's going on with the weather. So the PhD was trying to figure out ways that we could essentially predict what was going on with the melt rates without that high resolution data, without measurements actually in the mountains. Can we extract clues from what's going on the large scale, where we can have a pretty good idea of what's going on from few measurements? Can we extract enough information at that scale to figure out what's going on at the local scale of glaciers? So that was the PhD project.
And were there any kind of exciting outcomes from the project?
There were some innovative technical developments, I would say, from the PhD, but I wouldn't say many people outside of the field of glacier-climate interactions would find them exciting. What perhaps was more exciting in the PhD that will connect with more people was the fieldwork. So that's actually really what attracted me to, if I'm honest, to that particular PhD and the program of work, was the opportunity to go and spend a lot of time in the Arctic on glaciers, in the mountains, putting up weather stations. Found that really exciting. I love the mountains, and it was a really fun thing to do, if I'm honest, to go to these remote locations and to bring these data back, to analyse them, and to feel like it was all part of something that's important. And the importance here, in case it's been missed, because I often forget to state the obvious in these things, is that glaciers are really important water sources for people. And as they retreat, as the temperatures warm, that water source, it changes. The characteristics of how water is delivered to people downstream changes. And it may be that we see less water or less reliable water supply from those glaciers. And glaciers also, when they melt, they raise sea levels.
We'll kind of touch on the fieldwork a little bit more in a moment, but just before I forget, do you have any regrets not doing a master's? Because I think, again, a lot of people that finish their degree, they don't know whether to go straight to do a PhD or to do a master's first. And it is something, because I would like eventually to do a PhD, so I am interested to hear what your kind of thoughts are on that.
Yeah, it's a tricky one, that, actually. I'd say when I started my PhD, I perhaps, in those first, I'd say 6 months, reflect on the fact that perhaps it would have been helpful to have another piece of substantial writing, another piece of substantial independent research under my belt before taking on a PhD. But after that 6-month period, no, I don't think I've ever suffered from not having a master's. A master's in a very related discipline would perhaps be an advantage. And also the experience of writing a big piece of independent research can also be helpful. But really, in the scope of PhD, you have 3 to 4 years if you're doing it full time, longer if part time, devoted to really mastering a very narrow topic and learning how to do the analysis, how to write it up. That's sufficient, I would say. I don't think you need a master's to qualify you to do that. If you can find a master's that will perhaps give you some technical skills, that discipline, the PhD discipline will require, then it could be worthwhile. If it's some type of, a suite of statistical techniques that you think you'll need, or computation, something to develop your toolkit, then that could indeed be helpful. Because what you'll get from the masters is you will get guidance from academic staff that will help accelerate that process of learning. Is it critical across the board for PhDs? No, absolutely not.
I think that's really useful bit of advice, because I think a lot of people feel like it has to go in that chronological order: undergraduate, master's, PhD.
One important technical caveat I should add is that some universities make it a prerequisite, because they just need further evidence, essentially, of your ability to work independently on those bigger projects. But where it's not a requirement, there's good reason it's not a requirement.
Okay, so we've covered you've got to your PhD. So where did you go after your PhD? Because did you stick around at Loughborough again, or where else has this taken you?
So I didn't stick around at Loughborough. People would be delighted to hear that I have seen other parts of the world. I haven't just been rooted to the East Midlands. So I went to Ireland after Loughborough and took on a lecturing job at Maynooth University. Fantastic place just outside Dublin with incredibly supportive colleagues. So Maynooth University hosts the Irish Climate Analysis Research Unit. It's a really, really top research unit in Ireland. And there I moved from PhD looking at glaciers and climate, and very fieldwork based, or rather fieldwork had featured very strongly in the work, to a place that was famous for looking at weather and climate and the impact on river runoff in Ireland, and therefore my research focus changed. So I started looking at storms that hit the UK. So I was basically the atmospheric. Sorry, they would kill me if they heard what I just said. The British Irish Isles, not the UK.
Reel it back in quickly.
the two islands, being the island of Ireland and Great Britain. So I was basically the atmospheric side of their research group for a while, or at least one of the main people looking at the atmosphere, so the drivers of the weather events that produce really high and really low flows in Ireland. So I was there for 18 months, and really, did I enjoy my time there? I enjoyed the people I worked with, I enjoyed the research. It was a stressful time though, because you're going straight from a PhD into a full-time academic job. It's like starting any demanding career. That's a tough time, but really great opportunity in terms of opening my eyes to more research fields, bigger research questions, and an incredible group that I worked with there. They're really inspirational. So that was 18 months, and then I didn't come straight back to Loughborough. I managed to stay away a bit longer. I worked in Liverpool for another couple of years after that, lecturing at Liverpool John Moores University, and again had some really great colleagues there. And it was there that I really, I suppose, became more independent in my interests. So that's where I really started to work on weather and climate extremes, and hot weather in particular, and the danger it poses in particular to people in the tropics under climate warming.
Okay, so no more kind of river research when you were at Liverpool. Left that in Ireland.
It's all everything accumulates throughout your academic career. So you carry on basically doing that stuff and working with your collaborators there. And then I just developed, I suppose, another string to the research bow, and rather a new thing was added to my field of interests. And I'll be honest, the interest in hot weather came after a holiday to Vietnam.
Oh, okay.
So I remember going to Hanoi in June of, I think that must have been 2015. And of course, some of this just sounds all too familiar, and you think, well, why on earth were you surprised? But it was extremely hot.
Was it hot?
To the point, I'd been to West Africa before, I'd been to North Africa before, I've been to South America before, all right on the equator there in Ecuador. But this was different. The heat was extraordinary, and the way you can see the way in which people are living their lives, it exerts an enormous control over the things they do on a daily basis. And I remember, I suppose, what struck me was that there just wasn't much space between what we had there then during that very hot period of the year and a point at which everything would kind of shut down because no one could do anything during the day. And recognizing, you cannot get away from climate change when you work in the field of climate science. Recognizing that safety margin is being cut, I thought this is really, really pressing as a research field. The other fields I work in, glaciology, storms, certainly in terms of storminess in this part of the world, we expect changes, but the changes are relatively subtle compared to extreme heat and what's going on in places that are already very, very hot and humid. So that was really the light bulb moment for me in terms of a climate impact and a vulnerable community. And I don't mean, let's say, a vulnerable community, I don't mean the people of Vietnam per se. I mean, really, humanity in general. We all suffer pretty much. Certainly the vast majority of humanity suffers from hot weather at some point during the year. One of the biggest killers in the US from natural events is hot weather. And we know very little about how many people each year are dying in the likes of West Africa, South Asia, because we don't have the records, but you can bet it's already severely interfering with the way in which people lead their lives, live their lives rather. So that was added when I moved to Liverpool.
So how did we get from Liverpool to landlocked Loughborough again? Was there any in between, or did you come straight from Liverpool back to us?
Straight from Liverpool in 2018. So I was excited to join Loughborough again. Loughborough is, for my research, very, very strong, and it does some really good stuff in the Department of Geography and Environment that I now sit, looking at that interface between climate and climate change and its impacts on people. It's kind of a growing strength of the department. So being pretty problem focused rather than discipline focused, I would say. So discipline focused would be looking at questions within physical geography, elements of glaciology perhaps. In the department, there is definitely a focus on starting with perhaps a problem, and that is water security in the Himalayas or down in South Asia, and then working backwards from that. It's not an exclusive speciality of Loughborough, it's not exclusively what we do, but it's only a flavour that's developing in the department that really suits my interest. So I love that flexibility to be kind of problem focused.
You came to Loughborough initially for sport. Have you, your second time round, have you got back into the sport at Loughborough, or is that still on the cards?
No, I haven't even turned out for this, the geography department football team. So I shouldn't either. Football was not one of my sports. I did score a 50 in the first cricket match that I played for the department. I think the opposition took pity on me. I think I was on 44 or something going into. Well, the game was over and they had an extra over for me just to get to 50. So that's been my peak sporting achievement at Loughborough recently.
I know very little about cricket, but I'm going to assume that's good. So congratulations on that.
Also, I was a bowler when I used to play cricket properly, so it was a bit of a novelty getting some runs as a batsman. But no, I run now. That's an independent sport. So very, very much fits the kind of independence of being an academic now.
Okay, so we've just covered quite a journey spanning many years. You must have collected some really fun stories and kind of weird and wonderful moments. Are there any kind of standout field trips or moments that you can kind of share with us as part of that journey?
Probably the safest ones to share.
Safest.
Not necessarily the most memorable or the funniest, but I remember very early in my academic career, and kind of actually a low point to start, kind of a not great starting point. My academic journey was a weather station installation on my PhD glacier, the main glacier I worked on, which is a very famous glacier actually called Storglaciären in northern Sweden, and that translates as the big glacier in northern Sweden. And it's actually pretty small, 3 square kilometers, maybe even smaller now. But very famous because it has some of the longest measurements of any glacier in the world. It goes back to 1945. People have been measuring how much ice is there on an annual basis. And my PhD was putting up weather stations on the glacier and monitoring the weather throughout the whole year. And I think it was after my first fieldwork season, at the end of the summer, I was getting the station ready for the winter, and that's kind of a big thing because no one's going to be there. Well, give or take, but you're not going to see that station for probably a year. And you know that the wild weather is coming. You know, there's going to be lots of snow, there's going to be strong winds. And actually that site has the record for the strongest wind recorded in Sweden at over 80 meters per second.
Wow.
And 80 meters per second wind lifted off buildings, cabins that were 10 meters long, 2 meters high, and 5 meters wide, lifted them off their foundations and moved them. Smaller buildings were actually kind of blown into the river. Really extraordinary stuff. So you know that weather like that's coming. So okay, I'm going to get this ready for the winter. And to cut a long story short, my preparations weren't as obviously as good as they needed to be, because when I came back the next year, the weather station was completely folded. It was like it had been heated up, you know, to a really high temperature and just melted. It was phenomenal. So I still don't really know what happened to it, but I think what happened is ice accumulated on the station itself. So you get this rime ice accumulating, and that gives a really large surface area. The wind then blows on that, and it's just too much. So it was completely ruined. Luckily, we kind of had some extra pieces and, you know, different masts essentially to fix it and get it going again for the next summer. But yeah, that was quite an eye-opener, I suppose. And actually, if anything, it was also quite exciting, because you think, wow, this weather really is wild. And there were some amazing things I saw in that relatively modest Swedish Arctic valley, actually. So coming back and seeing what avalanches had done during the winter and the spring, again, completely buckling enormous metal girders that were there to, in this case, it was actually supporting a river runoff station. You know, really strong bits. I'm not sure what they were. They were metal girders, really, really strong, steady things. Kind of things you see in a skyscraper, completely buckled again. The power was incredible to see that landscape could exert. And that's quite inspirational, actually. But that was one of my first experiences with the weather station. So I didn't start well, I would
Big
say.
Oops.
It was a little bit, yeah.
And is there any kind of unusual things that you've had to do that you thought to yourself, I never imagined I'd be doing this as part of my academic kind of career?
Well, actually there are loads of those, but one that sticks in my mind was again on the same glacier, because I distinctly remember the conversation I had with the guy I was doing this with. And if he's listening, it was a guy called Joe Pomeroy, who's now Dr. Joe Pomeroy. We did our PhDs together, and we were working on that glacier, and we'd help each other out. He was doing different topic, but same region. And this particular day, he was installing these really cool sensors called geophones. They're like microphones, but deployed to listen to tectonic processes within the earth. And in this case, what was novel was they were being deployed to listen to sounds that the glacier would make. So they were being deployed on the glacier. And again, this might be a surprise to people listening, but glaciers make some really weird, creepy noises. You know, they are blocks of ice that are hundreds of meters thick, kilometers wide, and they are slowly sliding downhill. You don't perceive it when you're standing on them, because they, you know, a typical speed for Stor Glacier is probably in the order of, I can't even, well, probably won't bracket this very well, but tens of meters per year. So you're not seeing much movement on a daily basis, but you will occasionally hear these cracks coming from the ice, and it's a very deep sound because it comes from well within the ice. There's a huge mass that you're hearing move or fracture. And what Joe was interested in doing was putting these sensors out and listening to those noises coming from the glacier and seeing whether or not they were connected to weather events, that kind of thing, you know, causing temporary speed ups in ice velocity. The reality of installing these things was anything but technical and anything but glamorous. It involved digging pits on the surface of the ice, and digging a pit in the ice means carving out a hole with an ice axe, basically. It's like, you know, chiseling off an enormous ice cube, or chiseling bits of an enormous ice cube. So you're there with your ice axe, hacking away to create this little trench. And then you place the sensor, actually the box the sensors inside the trench. Very, very simple laborious work. What was memorable about this day was the weather. This will resonate with anyone listening who's been in Britain during the winter. But it must have been, this is the Swedish summer in the Arctic. It was, I think, about 3 or 4 degrees, and it was raining heavily and it was windy. It was about pretty much as cold as it gets before it snows. And I remember digging these pits with Joe, and they were just filling up with water. They were filling up with water that was running off, the rain that was running off the ice, some ice that's melting. And there are these ice blocks in the trench that's filled with water. And it was just the most depressing place on earth at that point. You're knee deep in an icy puddle. And I remember Joe telling me at that point that he'd considered doing a PhD on, it was something to do with beaches, and it would have been working in the tropics. And I thought at that point, yeah, this is probably the lowest point in my fieldwork journey. This is absolutely horrible. It's the closest I've been to being hypothermic, I would say. The work is the ball. You can't feel your hands. You're scratching away in an icy puddle to drop a box in, basically. It's not glamorous. It's painful. And yeah, at that point, we were both reflecting on what on earth we were doing with our lives. There have been better times since, but yeah, that I can still remember that quite distinctly. And that's now it's about 10 years old, that memory. But I can feel the lack of feeling in my hands. I can remember that clearly.
So what keeps you kind of motivated and driven after all this time working in academia? And are the things that inspired you to get into the job the same things that still inspire you now?
That's a very interesting one. And the things that sort of keep me going now, or rather motivate me, sounds like I'm on the edge of giving up. Not. The things that kind of get me excited now are finding out new things. It really is exhilarating to find something out, and to follow the thread through from when you have an idea. And ideas are never totally your own. They're always a mix of everything, everyone you've spoken to, everything you've read. The ingredients aren't yours, but the cooking pot is. So that's your mind, and everything's swirling around, and you'll think of something, you'll put things together, perhaps not intending to. It comes out on a walk, on a run, you have an idea. And then you don't follow through all ideas. You don't have time to follow them through, but some you do. And then as you're progressing, some end up, you don't find, you can't find out what you wanted to find out, or something happens, you can't carry the research out to its entirety or see it through to its entirety. Other bits you do, and sometimes you find what you're expecting to find, which is a great confirmation of the hypothesis that you may have had. Sometimes you find out something completely different, a big surprise to you. And either way, the satisfaction and the kind of exhilaration that comes from finding out something new, something surprising perhaps, is really quite addictive. So that really does keep me going, especially when you're doing that because you think the topic is important, it matters to people. There's a really, really satisfying thing to do, to know that you're finding out something new that can be useful. So that's probably what drives me now. And of course, I'm applying in a field that I find interesting. These extreme weather events, these extreme environments, what I've always been interested in. So even when I was fantasizing about working as a doctor or a policeman as a kid, the things that really got me excited were the outdoors. I can still remember the thunderstorms and the kind of living in, or the state of anticipation and nervousness and fear as the big thunderstorms were happening in the summer when I was a small kid. Always had a big effect to me. I was always fascinated by them. So the fact I'm doing all this in a domain that I can picture these weather events, I can picture these environments, that really keeps me going and drives me forward with the questioning. I originally got into all this because of the environment, being places. So I hinted at it with the field work during the PhD, that I did the PhD, so great, I get to spend all this time in the mountains. I get to be outside all the time. And I still like that, I find that exciting, but it's not actually the thing that I do on a daily basis. If I was in it for the field work, then I'd be very unhappy for 99% of the job. Now I find it's the kind of the cognitive or mental journey that is as exciting and sometimes more exciting than the physical journey of being somewhere, because you live your life in your mind, and if you can be in these environments and be kind of grappling with these issues, and you can recreate that really vividly in your mind when you're answering these questions. That's tremendously satisfying. And I found that has been something that's driven me forward more more recently in my career than why I got into this in the first place. I still love going to those environments, but it's the ability to conjure them up and to have those questions and to be thinking of things in your mind that I find really powerful.
That's really interesting, because I think a lot of people pick kind of careers around how much they can get to travel or work in the field or do practical things. So it's interesting to hear that that's kind of changed slightly, though the interest is still there. So we've touched on it quite a bit, that your job's very varied, can involve travel and bits and bobs like that. What would you say is the most exciting, if you have to pick one bit, what's the most exciting part of your job?
Well, I would say something that will fairly capture everything. It's freedom, I would say, is the most exciting. You can point to individual experiences, places to go, people to meet. But I would say the freedom is the thing that's genuinely exciting. You can do, obviously, with some bounds, but you can do pretty much anything in terms of how you organise your ideas, what you want to pursue. The sky is kind of the limit, and I find that the most exciting.
And on the flip side of it, what's not the worst part, but the not so glamorous part? So I often find when I talk to academics, there's lots of sighs about rejected publications, or a grant application has been rejected. So are these kind of the not so glamorous bits people don't tell you about?
Yeah, that's a good one, actually. So rejection from by journals is incredibly frustrating. It's something that it loses its kind of it loses impact over time, I would say. The first paper I submitted was rejected, and that had I was heartbroken by that one. Now you shrug your shoulders and you think, damn. And often there's a sense of injustice, but I mean, these things happen. I wouldn't say necessarily that's the worst thing, though, because it doesn't happen that often. You might submit as a lead author anything from none to 4 or 5 publications a year. So most, you realistically, as a lead author, when you take most responsibility for things, you're getting that kind of rejection a couple of times a year at most, I would say. Really unlucky if you get it 5 times a year. That's not much. Once every 10 weeks or something. What happens more often that is less fun is some of the administration that goes with any job. And there's not a huge amount in academia. We have great supportive colleagues in to do much of our administrative work, but there are always bits that you don't want to do, but you have to do. And I think that's kind of, if I was, let's say, listening to this as someone about to embark, thinking about what to do in their career, I'm going to suggest that any job that you may end up absolutely loving, and you might think you love it now, and that may end up to be true, there will still be parts of it that you'd enjoy less. And because it's all a relative thing, and the bits you enjoy less, because you have to do them, you end up really not liking them. It's a universal thing, I think, that dream jobs have bits that are less dreamy, and when you're operating in this dreamy state, the relative matters. So you focus on that negative bit will always be a chore to get through. And for me, it's anything related to administration. I know I have to do it. I have to get through it, get it done. So I imagine every job out there has those equivalents. If it's not administration, it's something else. If you're a paramedic, it's probably checking the bandages are up to date. There'll be something that's a procedure that isn't the core to why you're doing the job, but it just has to be done. And I think it'd be interesting to see if those people listening to this about to embark on their career journeys think about this conversation in years to come and see whether it rings true for what they're doing.
So obviously you really enjoy your job from what you've just told us. What's your is there an end goal or a certain goal you want to achieve? Like, what's the dream with where you're going forward?
Big question, Meg. Very, very big question. So I think, it probably resonates with lots of people when they think about their ambitions, but the different scales to consider. So often I think, and I imagine this is quite common, kind of get lost a little bit in the short-termism. So the short-termist view of my ambitions is to keep researching the things that I think are really important, and I'm passionate about, want to keep doing that research. Ultimately, though, the big question is, professionally, where does that lead you? What's the end goal? And I suppose it's an environment where you can do more of the important research that you think needs to be done. And in this field, or in this career space I'm operating in, it's probably having a research team around me that are working on those issues, because there's only so much time in the day, and there's only so many resources at my disposal as a researcher. And I think there are some very important questions that need to be answered in the context of where we are. The climate's changing pretty quickly, and there are lots of potential surprises out there. And the sooner that we can identify them and kind of highlight what risks there are, who may be at risk, and what can be done, the better position we're in to avert them. And being part of a larger team, having more resources at my disposal. And I don't mean, you do this, you do that, but having other like-minded scientists that can all drive forward the same overarching research agenda, that would be very satisfying, and I think very useful.
So let's now talk about aspiring scientists listen to this, or people thinking of picking a degree or already studying for a degree. If they are interested in climate science, what do you think, pardon the pun, will be the hot topic areas for them to explore, and why?
It's a very good question, a very difficult one too, because I can say what I think right now is the most important, but will that be the same in 10 years time, in 20 years time, in 5 years time? I don't know. I mean, right now, the two things that are pressing in terms of climate impacts are broadly water, full stop. Too much, too little. The same things that we worry about on a daily basis now. If you look back at, humanity's history and society's history, where we've settled, where we've avoided, and where we sought out. You won't find the old parts of, in this country, villages flooded that often. And likewise, you won't find people living an awful long way from rivers. Water is fundamental to the way in which we built our societies. We don't want to be places that flood, and we don't want to be places that are too dry. How the water cycle changes, and it will change, it is changing with the warming climate, it's critical. There's so much research in that field of hydrology and climate. So that's going to only continue as a field. There are more people on the planet too. We expect population to peak around mid-century. So water being used by more people, and more people perhaps being in harm's way. So in terms of spheres of research, water and climate is going to continue to occupy a very large part of that sphere in terms of importance. Now, heat, there's a reason why I've selected it to work on. It's going to continue to rise in importance, or we're going to read more stories about the impact of heat on people, particularly in the tropics, as the climate continues to warm. Again, we have the unfortunate correlation. This time it is a correlation of population growth rates and increase in dangerously hot weather, spatially coinciding. Those two things coinciding, so that's the correlation. In the tropics, populations are growing fastest, and the chance of encountering dangerously hot weather is also growing fastest. So it's a terrible coincidence, and it's not necessarily a coincidence, but that's another kind of thing entirely. That's going to continue to grow as a field in terms of importance. That's very much on the impact side. Now, climate change is a very broad topic, and over the next 10, 20 years, we have this critical period, and really the critical period is right now, coming out of the pandemic, trying to rebuild the world's economy. This critical period for how we build back, and how and if we can become carbon neutral in time. We have a budget of how much carbon dioxide, greenhouse gas in general, particularly carbon dioxide, we can emit into the atmosphere. And we don't have much of that budget left. So we have to cut down as a matter of absolute priority, unless we want to really roll the dice and see what happens. There will be surprises if we allow the climate to warm. There are already surprises kind of, lined up. the surprises get potentially more impactful and more surprising the further we allow the climate to warm. And we really have to keep the climate to no more, the global temperature no more than 2 degrees above this pre-industrial baseline. And we don't have much carbon left to emit before we do that. So there will be a lot of research in the next number of years about trying to do that. So renewable energy, or drawing down CO2 from the atmosphere, perhaps even geoengineering, how we do things like cool the planet of the Earth, the temperature of the Earth, even if we're increasing greenhouse gas concentrations in the atmosphere. The kind of ideas that seem better placed in science fiction, reducing the power of the sun, or the amount of sunlight that reaches the Earth's surface, those kinds of research questions that are designed to help us deal with the warming that's coming, or preventing the warming that's coming. I see that as a field that's going to be very big in the next 10 to 20 years. Moving beyond that, we'll know, towards the end of my career, we will know whether we did that, whether we succeeded. And if we haven't succeeded, then there will be an arms race, if you like, against the climate that's coming, adapting to it. It may mean that we have to move from certain parts of the Earth's surface. It may mean parts of the tropics are uninhabitable, or rather that we have to, and this is kind of big picture thinking, that we have to learn to live in a way that's independent of the climate. If we were to extrapolate tens of thousands of years into the future and remove the impact of global warming that we've created, you and I right now might be sitting under an ice sheet, because that's the natural progression of things. We oscillate between these very cold periods and these not so cold periods. That would also be a tremendous disruption to societal functioning if we had an ice sheet sitting over the Midlands of England and over much of North America. So this kind of, right on the horizon, we still have those pressures. So towards the end of the century, won't be that we'll be worrying about, but it might be a much warmer climate if we fail to really get our carbon emissions under control. We will be faced with that and trying to learn how to live with a very different climate than any of our ancestors have encountered. We're right now benefiting from kind of 10,000 years worth of fantastic development in human civilization. And we may be dealing with something that none of those ancestors encountered in the second half of the century, in which case climate research would all be about this kind of arms race, learning to live with the very changed conditions we face, and also trying to figure out what on earth is possible in that world. How hot can it get? How strong are the storms? What does this mean? Where can we safely live? They might be the questions we'll be asking towards the end of the century.
It's definitely a scary prospect when we talk about the future in that way, and how vital research like this is. But I think it also goes to show as well, kind of on a positive note, that there is going to be need for scientists in this field, and there is going to be opportunities for aspiring students, scientists, if they do like this, that it's definitely a needed area. So, okay, we've solved the case for climate scientists, why, students should consider this. So what are your words of wisdom if they do feel inspired by what you've said? What do you advise they do? Is there anything you wish you told your younger self?
Yeah, that's another big questions, Meg. Very, very, very big.
Very deep podcast, this.
Yeah, so, if you look at where I am, what I'm doing right now, the trajectory that I followed probably wasn't the best one to get me here, but I am here. So it's very hard to give advice, because I would say, technically, what do you need to be doing this kind of work? Well, you need to not be scared of numbers. You need to know enough physics to answer the types of questions that the climate system and the weather will throw at you. So you need those technical skills. And in terms of the basis to give you those technical skills, you should be studying maths and physics at A level. That's the kind of standard advice to give. But I didn't, and I'm here doing this. If I had done that, perhaps I would have chosen another degree. I wouldn't have got exposed to the environments that really turbocharged my interests, and I wouldn't be here now. So I would say, if you want to do what I did, then maybe follow the same general advice. Follow your interests at every stage. And for me, that led to geography. It led to physical geography, and then this particular path that got me here. But I would say follow your nose. It might be environmental sciences. It could be physics. It could be maths. It could be biology. It could be geology. Just follow what you find most interesting. In terms of, I'm talking about the immediate trajectory where you go off to follow A-levels and then university. You'll know, if you think about it for long enough, what subjects really excite you within that space. And just don't be afraid of following your interests, I would say. Because if you really think you like what I'm talking about and you want to end up here, at every junction, follow the one that seems to make the most sense, which one draws you the most. Don't worry too much about lining up where you are with where you want to be. If your interests really are here, you will get here. Just don't, well, it might be difficult for you to study English literature and wanted to be a weather forecaster, but if you want to work somewhere in environmental sciences, don't worry too much about the minutiae of that journey. Just follow your interest every stage, and your interest will evolve, and that's fine. You might end up not quite here, but doing something else you enjoy. But the bigger reflection on all this is that maybe you can't give advice. You just have to kind of walk your own path, because no two journeys will end up in the same place, almost by definition. It's hard to really verbalize what I'm thinking, or put into, make it coherent. But I don't think you can redesign this. I think you can set off in a direction, but there are so many complexities along the way. There are so many junctions, and to try and map out the journey is almost impossible. Do you picture, when you drive home every day, do you imagine the whole route, or do you just know what you do at each junction? Do you just remember, when you look back on it, the traffic light that you nearly ran through, the roundabout that you nearly pulled onto too quickly? You remember the individual junctions. It's too much to keep the whole journey in your mind. If you're driving across the country, for example, too much to remember the individual journey. You remember junctions. And I think that's the way to kind of think about your future. Each junction, choose something that makes sense to you in terms of it's not against what you think your overall interests are, and just do the thing that you enjoy most at each point. And you'll end up somewhere, if not here, somewhere close by, and in a place that hopefully is satisfying. I know that's very vague advice, but
no, I think that's great. I think sometimes that's an issue when people have too much structure and they're so narrow on their end goal that you miss all these wonderful opportunities on the way that could take you to something amazing. So I think that's a nice way to put it. Just enjoy the journey and see what arises.
The simpler way of saying getting some of those points out is, you might not know what you enjoy yet,
Yeah, very good point. So final question, why should people consider being a scientist?
Well, yeah, it's a good one. Well, I would say it's kind of very similar to why is science important. And science, I would say, is very important because it's one of the very, very few tools that we have to make sense of anything around us. Science is not an answer, it's a way of thinking, it's a way of doing things that's as objective as it possibly can be. It's a way of updating what we know about the world. That is so important. It has got us to where we are. Like, whether you think we're in a great place or not, everything that elevates us above the animal kingdom, we can almost attribute to science, in terms of the length of the lives that we now lead, the warm environments that we now live in, the shelter of our houses, all been arrived at through science. Science just is the objective pursuit of knowledge, and I think that is really critical. Looking forward, we're in a world where, whatever your political allegiance may be, we're in a world that we are very at risk, or very susceptible to disinformation. And science is really the way that we can navigate that complexity. And I think we're at a time in the world where everything is changing extremely quickly and the stakes are very, very high. And as a society, I think all we can really hope for, regardless of your worldview, is that we're well informed to make decisions. So whatever we want the end goal to be, we want to make sure that we walk the right path that lines up with that end goal. And science is the way that can show us the path. It tells us how to get from A to B. If you do this, this will result, not in complex social situations, but in terms of understanding the world around us. Climate change is a great example. It doesn't matter if you don't want the world to be warming. It is because of this. You can have a world view that climate change is kind of incompatible with. It's inconvenient if you're an ardent capitalist that has investments in fossil fuels. Extremely inconvenient. But the truth is the climate's warming because we're putting greenhouse gases into the atmosphere. So science is critically important if we are going to walk the path that we want to walk. It's a way of seeing through this disinformation, and it's a method. If you like, it's a sound recipe book for being rational and logical. And being a professional scientist, I find that's really helpful for navigating things in kind of personal and private life too. You think, hang on, this can be approached rationally. I can choose the best day to do whatever as a function of the probability that I will be free on that day. Small things like that. Or if you're choosing to buy a house, you can come up with a scoring system. Rationality helps, and science is the ultimate manifestation of that rationality. And the other end of the scale of why you might want to be a scientist, well, if you end up doing a job like this, you get to really choose what you study and the field in which you're trying to move understanding forward in. Tremendous freedom and satisfaction. But as a general point, the general point is science is, I think, really important for society, particularly now. As kind of a personal career choice, it allows you tremendous freedom to contribute positively to society.
I mean, a powerful answer to finish off the podcast.
A long answer, I apologise.
No, long but necessary. So thank you so much for taking the time to have a cuppa and a good chat with us. Is there anything you want to plug, Tom, before we go? Twitter, website, anything like that?
Oh, I was going to say no, but it just occurs to me, yes, you can follow Everweather on Twitter. So Everweather is a live feed from the world's highest weather stations. It tweets as soon as a new observation comes in from one of the weather stations. So the South Col being the highest it's tweeting now, 8,000 meters. Camp 2, Base Camp, and they're the only ones that are tweeting. But I think it's easy to take that for granted in the modern world. But these things are sitting there, 8,000 meters the highest on a Himalayan peak, tweeting on the hour. I think that's an extraordinary little privilege to get insight into what's going on up there. So I very much enjoy following the weather stations, and I hope to pick up a few more followers from this. So,
definitely worth a follow, and I'm sure the Everest account tweets better tweets than I do from landlocked Loughborough. So
yeah, it's automated, so it's not too imaginative. It tells you the weather up there, and you can enjoy thinking, well, at least it's not minus 20 in Loughborough today.
Be grateful for what you've got.
Exactly.
Great, thank you so much.
You're welcome. Thanks for the opportunity, Megan.
So thank you all for listening or watching the first ever episode of Cuppa with a Scientist. I hope you found it interesting and that you'll join us again. Do leave a comment and get in touch. I'd love to hear your feedback and thoughts on who you'd like to see on the show next. And make sure you don't miss the show by subscribing on Apple Podcasts, Spotify and other mainstream podcast platforms. You can also subscribe to the Loughborough University YouTube channel if you prefer to watch the show. We hope you'll be back for more hot tea and even hotter stories to help you on your way to becoming a scientist.